Okay.
Yes, sir.
Let me share my task screen. I believe you can see my screen now.
Not yet. Okay, yeah.
Okay, so um, with let me go over exploring R again. I think so that we can go over it again and try to solve the issue of that people can't get what I was doing over time sometimes. That's on Saturday. I think Titi made mention of that. So I'll just go over some things we did in this session. This is the third session of module 2. So in this session, we talk about exploring R and what are the so here we talk about distinguish between the GUI, which is our graphical user interface, and the R Studio and their components, and developing scripts for execution in R, and also how to execute develop scripts. So I think it's just the practical aspect. I'll just go over again. So let me talk about this part of R Studio. I think I've already distinguished between the R GUI and R Studio. So this is R Studio. This is R Studio. So this is R Studio. So I want to open a new script. So this is R Studio. Uh, this is the source window. This is the console. This is the work history and environment, and this is where we have the 5 dot packages and all the likes of that. And this is our RGUI. Sorry. This is our RGUI, and it's different from RStudio. This is looks like this is what it looks like. This is our RGUI. This is the console where you can type all the commands and run it line by line. And you can also write the code in a script, then run it. So if you want to open a new script, you can go to file, then new script, then you see something like a comes out where you can type your code and everything you want to type and run it on the console line by line. So I'm just going to close this. So going back. Um, so RStudio has some important features, which is code highlighting, whereby you can highlight your code and run it. Automatic matching, my bracket matching. If I open a bracket, it gives me the close bracket. Also, code completion. If I write any code, it can help me to complete the thread. Let's say I want to type append, which is a function in R. Don't give me, I can just scroll down and just click enter. It helps me with that. So this is very important in some cases whereby you want to use a function, but you can't really remember the name proper. But at least you have, the beginning. Maybe it's append app. By the time you just type something, if it's not showing giving you an option, you can press the tab button on your what's it called, on your Windows keypad. You can type the tab button, then it's going to give you option of the different kind of function you are trying to look for. Also, we talked about access to RHelp. You can use the help function or use the help function is HELP. Then inside the bracket, you can type the name of the function you're trying to get up. Question mark or double. If you want to find out about the sum function, you can type question mark and sum. Then run this guy. Control enter to run a single line. Then at this my left bottom, what is it? Oh, sorry, it's not going to run because I'm trying to run a, a, a loop here. So something is actually running in the console. So that's why this one is not run. Sorry. So also easy exploration of variables and values, whereby all the values you have created, the variables you have created, you're able to see it in this environment here. So far, I'll be able to create all these variables in my work, my current R session. You can see all the name of these variables. You can scroll down and see everything. Yeah. Um, and it's also available for free for Linux, Windows, and Mac, and it can be accessible by clicking the Ask Do icon in the menu system on the desktop. The shortcut is actually provided. You can just come to your Windows search here and just type out Studio. It's going to come up after you've installed it, as you can see here. Okay, so our Studio has different components: the source, the console, workspace history, file, plot, package, and help, which I've shown us here. This is the source, the one at the left top corner. The one at the left bottom here is your console, and this is your work history, work and history, which is at the right top, and this file, plot, package, and everything. Okay, so this is talking about doing simple maths in how to just your normal. It can help you to do your normal arithmetic. Also, you have these operators in R, the normal, addition, subtraction, division, and all with bracket. You have constant pi. You have the caret sign to do power. That's the power sign. So if I want to do 2 raised to the power 3, you can do 2 caret 3. Sometimes you can use double star. This star, this can still work same way as this. You have the square root function, and you have trigonometric function, and the log function also. Then you can find modulo and integer division in R. For modulo, which is to find the remainder, you can use the double percentage sign. I'm not using out today because I'm currently running something on out today. That's why I'm just using the out GUI here. So let's say I want to find 5 modulo 2. I'll just write 5 percentage 2, and it gives me 1. It means 5 divided by 2 has a remainder of 1. And if I want to do integer division, I can just do, let me increase this view so that, let me just enlarge this. It's not even, it's still not. How can I zoom in? Let me check what I can do. Control plus. Okay. So no problem. So you can do integer division using the double slash sign. So you can do 5, sorry, not double slash, percentage, then slash, then percentage with 2. This is integer division. So it's saying that the integer division of 5 divided by 2 is 2. That is, how many times can 2 go in 5? It's just 2 times. So that's just basically it. Moving forward, here we talked about using vector. You can create vector by using the C function. That's the combined function, you can call it, or concatenate, and just combine. Or you can use the colon to create a sequence of numbers, which is also going to be a vector. So is either I can use this to create 1, 2, 3, 4, 5. I can also use this to create 1, 2, 3, 4, 5. But this one is useful. This one is useful when you want to create a sequence of numbers. But in case whereby the vector, the things you want to create does not follow a particular pattern, in that order you choose to do it. So for example, I can do, let me to combine 2, 1, 3, 4, 2, 5, comma 6, then I'll close the bracket, then enter. You can see the numbers I just entered, just brought it out for me. But if I do 1 colon 10, this is just going to do 1, 2, 3 up to 10 in that order. So that's just the difference. Hello, can we all hear me? I want to admit someone to class. Uh, okay. So, okay. So, but can we all hear me? Can you hear me? Bello, can you hear me, Titi? Please let me know if you can hear me. So, also,
I can hear you, but it's breaking. I don't know if it's from my own network. This Titi.
okay, Titi. Um, oh, Ayala, welcome. How are you doing today?
I'm fine, thank you.
All right. Okay. So, this is just how to assign value to a variable. So here I'm creating a variable x and I'm assigning 1 to 5 to it. You can say I'm using less than and a minus sign, which means you can see the less than is facing the x. It means assign 1 to 5 to x. I'm going to explain what that means. So what that typically means is that I'm saying that, let me go back to my RGUI. I'm not using RStudio because something is still running. I'm still running something here, so it's not done as I'm using RStudio. So what it typically means that I want to say x is 1 to 5. It means 1 to 5 should be assigned to x. You know, the less than, the arrow is facing x. It means assign this guy to x. I can use equality sign. It's still going to work fine, but typically how uses this. So if I should run this, it means this guy has been assigned to x. So anytime I call x, it just brings out this guy. You can say 1 to 5. Now another way I can do this, this is the like the usual way of doing it, but you can do it this way too. I can say 1 to 10 is minus and greater than x. Now I'm also assigning 1 to 10 to x. You can see that the greater than is facing x, like the arrow is pointing to x. So it means assign this guy to this. So this is another way, but this is the usual way of doing it. So it's still the same. By the time I run this, now x is no longer 1 to 5, but now 1 to 10. So this assignment has already overridden what I did here in the first place, unless I gave x a different name. Since it's still behind the same name, so it's now 1 to 10. It's no longer 1 to 5. So if I call x now, you can see that x is now 1 to 10. All right, please let me know if you have any question at any point, please. So that
Okay, please, Emmanuel, I have a
probably carry on.
question. This Titi.
All right, Titi.
Okay, what's the difference between a vector and the variable?
And the variable.
Yes.
So you mean the vector that are assigned to the variable?
Yeah, I saw you did something in vector. It says a sequence of number, and you said to create it, you can either say 1 is to 10 in brackets, and then you have 1 to 10 out listed out, or you can put it in brackets 2, 1, 3, 4, 5, and when you run it, it's still going to give you that. Now I'm seeing another one again called variable that you can assign a variable to x, and when you call x, it gives you the series of numbers. So I just want
So it's
to.
just that.
Okay, I'm with you.
It's just that. Now I have this sequence of numbers. Now I want to be using this sequence of numbers. Are you with me? So instead of me to be typing this over and over again, I just want to give it a particular name called x. so that whenever I call this X, I will have this number. So it's just like a temporary location to help me to store something. Just like if you have a superstore, the superstore is just a building. What is inside it is what makes it a superstore. So it's a temporary location to store. The variable is just a temporary location, an object to store something. So these vectors or what is it called is being stored to this guy X, so that I can reuse this guy just by typing X. You understand?
Yeah, okay, yeah. Thanks.
So whenever I whenever I need 1 to 5, I can just call X directly instead of having to type 1 to 5 again in that regard.
All right, thank you.
Okay. Uh Here we created a series of number, a vector 1 to 5 to be X. Now here they now assign 10 to Y. Now if I do X plus Y, it means 10 is going to be added to each axis, that is each element in this X, which is 1, 2, 3, 4, 5. So I will have 10 plus 1, 10 plus 2, like that. So that you can so that you have something like this: 11, 12, 13, 14, 15 in that order. All right, moving to the next slide. I have now a vector can also store string, that is characters. It's not only numbers. As you can see here, I'm storing hello, comma world to a variable called HW. So this HW takes hold of this vector. So here I assign this vector to HW. So by the time I call HW, I can see what is inside, which is hello and world in that regard. Okay. So moving forward, now I made mention of something on Friday, that a vector can only take a single character at a time, so a single data type at a time. You can't have both numbers and string in a vector. Is either it's all elements in that vector is a number, or all elements in that vector is a string. So it can't take both at a time. So, and also I also talked about having to get response from the user using a function called readLine, that is, which is going to prompt the user to input something into the screen. So here I'm saying h is equals to hello. Now, when you want to write a character in R, even in major like programming languages, they use quote. Either is double quote or single quote. So hello is a character, so I put it in quotes as this. And here I'm saying that your name is what? Read line into brackets. Read line will prompt the user to enter something. So I'm saying, what is your name? Which means by the time I run this line of code, it's going to give a prompt in the console requesting a user to input his or her name. So for instance, I come here, I write read line using the read line function into brackets. Then I can put a comment so that the person can know what I'm trying to request from him or her. I can say, how old are you? I can just type read line and just enter like that. But I want the user to be able to know what I'm trying to ask from the user. So how old are you? I can put a space so that let me put this here, let me put a space like this. So how old are you? By the time I press enter, you can see it's brought a prompt that how old are you? So the person will now enter it that okay, or you can just type 24, enter. You can see it printed 24. So this result, I can store it in a variable called age. I'll now say age is, so that I can do this. So the way I just did it, I just press the up button so I can recall what I just typed in the previous line. So I can say age is equals to this. So if I want this, it's going to ask the user, how old are you? Then I can say 24, enter. Now in this case, this 24 now has been stored into this variable called age. So if I type age now, it's just going to bring out 24, which is very interesting. Now, here they use a function called paste, which is just to uh, take one or two things together. Is similar to print, but it's not print. It's similar to print function, but it's not the print function. It's not. It doesn't work like the print function. But so it works like the print function, but the way they work is different. So here I can say paste h comma your name. You can say I'm trying uh, to combine two things together. H is what? Hello. Then your name is whatever the person entered. The person entered Andre here. So paste H comma your name is just going to paste what is H? Hello. And what is your name? Andre. So that's why you have hello Andre on this screen. Yeah. Okay. So moving forward, um, talking about sourcing a script. Say you can send an individual line of code from the editor to the console by just pressing Ctrl plus R. In that's in your RGUI, that is this place that I am here. Ctrl plus R. So that's if you are using the script. So let me open a script like this and type new script. This is a new script. This is like an editor. So if I do 10 plus 10 plus 10, and I want to run this line of code, I can say Control R. So did I? Sorry, not Control. Control R. Did I? Sorry. One. If I say run this guy now, I think it has been sent to this. But sorry, where's my console? Sorry. So you can see that it ran the command. So it just ran it multiple times because I pressed it multiple times. So this might not be flexible for you to use. So that's why the R Studio is prescribed to use when you run your R commands. So, but in R Studio, you use Control Enter to run a single line of code, or you click the run button. Let me show you the run button in R Studio, or you click this run button. Oh, so okay, this run button here. All right. So I think my code has finished running on R Studio, so I can use R Studio now. So also moving forward, I think we're almost done with this. Now, using ls function is used to see the variables you have created in your workspace. So you can see the list of variables you have created in your workspace. You can use the rm function to remove a variable from the workspace also. I will show you. Then you can save your work using the load. You can save the work you've done using the load function and just give it a name. In this case, they use file underscore name.rda. I'm going to see more of this also. Then I think that's just it. So let me show you how you can. So if I want to see the object I've created, I can use ls, then the brackets. If I want this, these are the objects I've created so far in this house session. You don't mind, there are a lot of them because I use R a lot. So if I want to remove an object, I can say rm, then rm rather, and I can put the name of the object I want to remove. Say I want to remove this object, VEC1. Now, first of all, before I remove it, I'll show you something. So let me type VEC1. Let's see what is inside. You can see this is what is inside VEC1. Now, by the time I remove VEC1 now, VEC1, I've removed it now. So I've run this command, it has been removed. If I should run this command again, to see what's inside VC1, it's going to tell me that object not found. Object VC1 not found because I already removed that. So that's how it works out. Now, next thing is to move on to reading data sets into R. That's the next session. Do you have any questions before we proceed into this session? Hello? Hello? Hello, can we all hear me?
Yes, can hear you.
Okay. All right, sorry, I want to check something. Oh, okay, no problem. So, what I'm gonna do now. So yeah, we're talking about reading data sets into R and exporting data from R. So here, import, we talk about import data from external sources into R and also export data to external sources from R. I don't know whether I talked about this last week on Saturday. I think I did, but let's move on. So now, I think I talked about it, but let's just go over it again. Now, so using the combine command, I think we've talked about using the combine command, C into bracket, then you list what you needed inside the function. This is to create a vector. Now, what I just did here is that, okay, I just given an instance, say I want to create a variable sample.name, and I want to put this item 1, item 2, item 3, up to item n inside this combine function. This is just going to create a vector of item 1 to n. So this is an illustration. Data 1 is equals to, you can see they use equals to here. It doesn't matter whether I use that other sign. So C into brackets 3, 5, 7. So this is going to be the vector of these numbers. Okay. Now, is Faida on this call? Is Faida still on the call? Now I just called data 1 to see what is inside. You can see it has created those numbers, as you can see in the previous slide here, where I put 357 with the C function. So if I just call data 1, it's just going to show me what's inside. And data 2 is just saying, okay, I'm going to join data 1 with all these numbers. So I created a data 2, is just an update of this data 1 with what? 4, 5, 7, 3, and 4 in that order. And here I'm creating a vector of characters, Monday to Thursday, Monday, Tuesday. You can see it's in quotes because it's a character. Then if I call it, I can see what is inside. Now, this one now is like I'm updating day 1. You can see that they didn't give it a different name, but this day 1 has overridden this day 1. So what just happened here is that I'm saying that day 1, which is the variable name I'm calling it, is what? A vector of day 1, which is this particular day 1, Monday to Thursday. Then I'm adding what? Friday to it. So by the time I call day 1 now, day 1 is no longer Monday to Thursday because I've added Friday to it, now Monday to Friday. Does that make sense to us at first? Hello? Can you hear me? Okay. I think it's okay. Thank you. I also talked about the scan command, which you can use to read text files, or you can use to read in values. You can copy and paste, you can type manually into the screen. By default, it takes in numbers, but if you want it to take in character, you put this parameter, say what is equals to character in quote, so that it will be able to take in character value. So I'm just going to demonstrate that. So let me just demonstrate that here. So yeah. So here I'm typing scan. Then let me run it. You can see in the console it's prompting me to what enter values. So I can say 2, 3, 4 with a space. I'm separating the values by space. Remember, 8, 4, and 5. I press enter. Now it's giving me 9 in this second line, meaning trying to tell me that maybe I still want to enter another value. Now, what the number of values I've entered is 8. So this is the 9th entry. It's starting, okay, enter is numbering it for me. But I'm done entering my values. So if I'm done again, I'll press enter again. So if I press enter again, so it's read what 8 items, which are the numbers I just entered here that just pop up here. Now, if what I want is a character, I'll put what is equal to character in quotes like this. Then control enter. You can see if I type 1, 2, 3, 4, 5. Now I press enter, then enter again. You can see it gave me. Now you can see that my 1, 2, 3, 4, 5 is in quote. That's the difference between this and this one I just did here. So it took the 1, 2, 3, 4, 5 as a character, not a number, because I've already specified this here. That's why the quotes. That's the difference between this and this. So if you see numbers in quote like this, you should know that they are character values. So it means you cannot perform arithmetic operation on them. So take note of that. And how do you even know? How will you even know whether a vector or what the numbers inside a particular vector are character value? Sometimes you might not be able to differentiate. You can just say, so let me just create a vector of characters. So VEC. Then I'll use the scan command. So I'll just take 1, 2, 3, 4, 5. Enter, enter. If I store it, let me see for you so you can see. So these are what is inside VEC. But then class into bracket VEC. If I run class into bracket VEC, this is going to tell me the type of things that are inside VEC. You can see it gave me what character. So it means I have character values inside VEC. All right. I can also copy and paste from a spreadsheet, but take note that scan can only take in whether only numbers or only what character value. Take note of that. So let's say I use the scan function like this. In this prompt, if I have something that I already typed that I want to just call it inside R, I can just go to my spreadsheet or notepad, just copy it and just paste here. I don't want to open this. So let me say a notepad. Let's say I already typed this babies. No, let me just use numbers since I use 23, 24, 56, 34, 21, 12, and 15. I have this already. I can just come here and copy it like this. Then I come here and paste it here. You can see enter. It tells me to enter what the 8th value. Just enter. So it's just read those things for me here, as you can see. So it's just as flexible as that. So it can also be used to read a TXT file, but remember that TXT file, you have to specify what it contains. If it's a numeric, it contains numeric values, you have to just use only the scan function. But if it contains character values, then you have to use something like this. So there's another parameter you can use. Say scan into bracket file.choose. I think I explained that last week also. File.choose. If I should run this, this is going to prompt give me a prompt to browse the file I'm trying to import. So I can just run this and it's going to pop up something now. So there's a pop-up here now. Where is it? So let me close this so I can see it. So this is the pop-up. It's telling me to browse the file I need to import. So I can just browse through and all of that. Then if I have any files I want to import, then open. Then going to open in the console. All right. So I can also specify separator. I think I also explained this on Saturday. If the values I'm trying to enter will be separated by comma, I will put separator equals to comma in quotes as they just did here. So if I enter my values, I will separate my values with comma. So it's I was going to understand that this is the first element, this is the second element, this is the third, like that, like that. You can use any kind of separator as you may wish. Okay. Um, as I said earlier, scan is used to what? Reading a text file. So you can see here I'm trying to read a text file called file underscore name dot txt. So I just put scan into bracket file is equals to this. Now, if this file is in your working directory, if you run this command, it's just going to work fine. But if it is not, you have to specify the location of where this file is to run this command. And to get a working directory, you can use this command get wd in the square bracket. It's going to tell you the working directory of your R. So, like where R can pick your files directly without having to, like the path, without having to specify the path. So if I want to know my working directory, my R, I can just type get wd and run it. So here, my working directory is what? Document. So it can access documents directly. And if I want to read any file from document, I don't have to specify the path. I just have to specify the file name. But if what I'm trying to get is from desktop, I have to specify that I'm going to desktop to pick this file. But if you decide to change your working directory to desktop, you can do that using the setwd command. Setwd. Then inside you put the location you want to put as a working directory. All right. Please, if you have any question, just call my attention to it as we proceed. So here you can see they use setwd to set desktop as their working directory. Then by the time you use getwd, it's going to tell you that okay, your new working directory is now desktop. Moving to the next slide. Sorry, I want to be sure that Bolo is there. Oh, sorry, Bolo has been. She has been in the lobby since I didn't allow her. Hello, Faida. Sorry, I kept you out for a while. So I didn't know you are out already.
My network logged me out. That's why.
All right, no problem. So I also talked about file.choose. So you can see here, this allows you to browse the location of where your file is easily. Probably you don't know the name of the file, you can just say, or you don't want to just, or you don't know the working directory, you just want to start searching for the file. So in file.choose, then you can now browse through your file explorer and choose the file you are trying to load. But don't forget, the scan function only reads txt file. So next. Now there are functions that I can use to read bigger files, like read.csv, like to read CSV file, read.table to read tables, or It can also be used for CSV files also or tab separated value. Then read dot delim is specially used for tab separated value. There are several functions you can use to read files. If you want to read a JSON file, there are JSON functions in R. Probably, I think you have to install the package to do that. You can read XML files, depending, but usually we're just going to be talking about these functions here. This is used to read CSV file. Don't forget. And I don't finish talking about this yet. So to export a file, you use the write.table command or write.csv if the CSV file, depending on the kind of file you're trying to export. So if I go to RStudio now, for example, if I type write now, it's going to give me several options. You can see several options to write files. You can see write.csv, write underscore, any kind of files you're trying to just work with. But write.table is can be accommodating, but you just have to specify the separator for the file you're trying to save. So probably I'm done working with the file in R, then I want to export it. Then I can use the write.csv or write.table to do that. So in here, I'm trying to export a file called file underscore name. Then I want to save it as what? Clipboard. Then I'm trying to say that the separator of that file I'm working with is tab separated by, so separated by tab. Then me putting row.name equals false is that I don't want to include the row names. So what do I mean by that? So for example, I have this data set, data into iris. This inbuilt data set in R. If I should call iris now or head of iris, I want to see the first 6 rows of iris data set. This is what's inside. If I want to export this row data set now, and I don't need this row index, all these 1, 2, 3, 4, 5, 6, they are row index. Then I will specify this parameter that you can see here, row.names is equal to false, so that I will avoid all those row index having to come up with my data. So also you can use the save command to save your workspace. This save is this one. I'm trying to save some variables in the workspace, so that I can reuse them later. So sometimes you might lose your variables. You don't have to start creating it over again. I'm trying to run everything over again. So you have it saved so that you can just use it. So if it's not there again, you can just load. Maybe I save these variables into this file, and I want to use them again. I can just load this file into my R, then I start using them again. So I can also use this pattern. You can see I'm saying save any variables that start with VF. So that is list is equal to ls in the bracket, pattern is equal to what? Caret sign VF. This is like a regular expression kind of statement where I'm trying to say save all the variables that start with VF. Instead of having to highlight all of this by one, I can just do this. I can save everything using this command. Say list is equal to ls into brackets odd equals to true. You know the ls command is the one that makes you to see the objects you have created. That's why you have this ls here. Then I'll say file is equal to the name of the file I want to call it, that I want to save it as. Okay. Then this one is to save the entire current session. Save that image, and I think that will just be it for this session. Now, yesterday, Faida was talking about something. I will show you when I get to the session. In this Next session, we'll be talking about manipulating and processing data in R. What are the objectives we are going to cover here? So, do you have any questions so far, please, before we proceed? Let me see whether Faida is not kicked out yet. Okay, is there any question before we move on again? Okay. So Faida, as you use your the way you use your Jupyter, Faida, can you hear me, please? Hello, Faida, are you there? Okay, so in this session, talking about manipulating and processing data in R. Now, what are the objectives we're going to cover here? Here we'll be talking about understanding the three success operators in R, perform data manipulation functions like subsetting, sorting, and merging of data in R. So I want to show Farid something. So everybody's going to also get from this. So like Jupyter Notebook, the way you run Python on Jupyter Notebook, whereby you can just run your stuff in a cell, then see the output underneath and just export everything as a single file, your line of code and your output at the same time. Instead of me writing the code here and the outputs can just be seen in the console or in this section. You can just see it on a single file. So you can use the R Markdown to do that. So you can go to File here, then New File, then you go to New File. You're going to see R Markdown here. Now, so something like this is going to pop up. You can give it the name. So let me say DASCA R Markdown. So let me call it DASCA R Markdown. Then can give the name of the author, I don't know. You can put it as HTML, but just what is HTML, of which you can export to PDF or Word output anytime. But let's just use HTML. Then okay, then you can see it brings this guy. Then here I can just click on. It's going to give you an overview of so that's what all of this is just saying. So underneath I can just clear these notations if I'm not interested, or I can just continue underneath here. So let's say I want to load the iris data. I've already loaded the iris data set. Now I want to see my any kind of statistics I'm trying to do. I want it to show in this area alone. I don't want it to come to this console. So I can just say do this. I'll click on insert to insert an R code one at a time. Then this thing is going to come something like this. So inside here, I can say for example, I can say head of iris, which by default is going to give me the first 6 rows, but I want it to give me the first 10 rows and put comma 10. This is going to give me the first 10 rows of iris. So if I should run this, I can click on this run button here to run it. So if I run this, you can see that it popped up, it came up just inside this it still came up on this page. So you can see both your line of code and your output just on a single page. And okay, I'm done with this. Then I want to do another thing. So anything you want to show on that page, you can just do this insert and put your code there and run it in this way. Then let's say I want to plot and I want it to show on this still on a single page. I can insert again. I want to start R script. Then say I want to plot. So let me just use the plot function. I don't want to use ggplot. There's a ggplot for this. So let's use ggplot iris. we learn about ggplot later on anyways. So ggplot this, what do I want to plot? A line chart. So I will say geom underscore line and do some aesthetic. My x is going to be plot sepal plot petal dot length with my y to be petal dot width. I hope Faida is watching this because she talked about this. So what do
Yes,
I
I
need to
am.
add again? Okay. So let's say I want to aggregate it by color with species, the species column. So I can say color. I want to like for each species. So color is got to species. I have a species column in the in the X data set. Let me show you. So this is species column. So color is got to species. Do I have anything to add again? I don't think so. So I think that's just it. So let me just run this. Let me see. I think I have an error. Oh, sorry. I didn't type this very well. June line. So let me run this again. So this is what I have. So I have this plot also on a line this way. This is the plot of petal dot length against petal dot width for this species setosa, and this is for versicolor, and this is for virginica on a single line. As you can see it like this. Now say probably I'm done with this guy. I'm done like this. I want to export this information. I think I can just do this. I want to convert this to PDF, and I can just save it as my DASCA report. Then I can just save. It's already saved under documents. So as you can see it. Let me go to documents. Uh, documents. Where is it? Okay, it's saved as this. Okay, so it's stored as a markdown. So let me see if I can export this guy now. I can publish document. I wish you can publish to cloud if you wish. Sorry. I think I'm having an error here. I think I have to come back to this. There's a way you can just export this. I think maybe you have to publish it. So we'll come back to it later, or I'll talk about it in uh, tomorrow. So this is exactly what the same Jupyter Notebook is going to do for you. You understand what I'm trying to say, right? So
Say
exactly what
Jupiter.
it does.
Abi?
Yeah?
You
This
said
this
okay.
like
Ah,
Jupyter Notebook, like exactly what it's going to look like. Your codes, your results in that manner. You understand?
how did you get to this phase? Sorry. The R markdown, how did you do it?
You go to file, then new file, then you go to R Markdown, then
Okay.
give it a name and stuff. So if I click on this, it will give you a title, select HTML, then okay, then you can export to PDF later. So that's just it.
Sorry, like my own this thing is saying error. Required package versions will not be found. Will I have to download something?
Okay, if it's giving you error, I think you have to install the R Markdown package. I think maybe you don't have the R Markdown package in your
Okay.
so you can install the R Markdown package. So let's proceed. Sorry for the shifting. Okay, here in this session we talk about understand the three subsets operators in R, perform data manipulation functions like subsetting, sorting, and merging of data in R. Now, first of all, we talk about deciding the appropriate data structures. Now, we have like six, I think we have like six data structures in the R, but most popularly we'll be talking about just four of them: vectors, matrices, lists, data frames. We have arrays, and I think we still have one. But for now, we'll be talking about these four. So vectors, we've seen how vectors is. Vectors is one-dimensional data which stores only one data type at a time. Either it is a character value or a numeric value. And we have matrices. Similar to vector, it can only take one data type at a time or character, but it's two-dimensional. Now we have list, which is used for higher dimensional data, like customer data information of an organization. List can take in anything, can take any type of data. Then you have data frames, similar to this, can take different kind of data type at a time, dates, numbers, character, but each column in a data frame is unique to its data type. It's just like a spreadsheet data. As I said earlier, I think we have six of those of data structures in R: vectors, matrices, lists, data frames, which we'll be talking majorly on. But we have arrays and we have tables. We have arrays and tables also. But we're just going to talk about this four. Okay. Now, how do we subset data? Please, before I proceed, I would like to take just, just give me like 5 minutes. I'll be back. Let me just give me 5 minutes. Okay, so sorry for the breaking. Uh, can you hear me? Hello? You can hear me, right?
Hello.
You can hear me? Hello, you
Yes,
can hear me now?
yes, we can hear you.
Okay, so we want to talk about subsets, how to subset data. Now we have three ways, like three ways. Now we have the dollar sign, which is going to give you just like a single vector, like a vector, just a vector, like a single vector. And we have the double square bracket with the double square bracket similar to dollar sign, but it returns a single element, but it offers the ability of referring to the element by position rather than by name. The dollar sign, you can only call those what you want to call by the name of what we're trying to call by the name. Let's say column. Let's say data frame now. You can let's say a column a data frame like employee data, which has employee ID, employee name. You can't call employee name. Let's say the name of the data frame is employee. So I'll write employee, then the dollar sign followed by employee name. This is going to give you the column that has what the employee name. That's what dollar sign is. But the double square bracket, you can use it to call them by the position rather than the name. So if I need a column in position 1, I can just do double square bracket 1 in that regard. Then you have the single square bracket, which returns multiple elements of data. But in some cases, it can return just one element. In case of a vector, that's in case of a vector. So I'm going to illustrate, do some illustration for us. So let's say, for example, before we proceed, I have this guy. I want to create a vector of 1 to 10. But I don't want to create it this way. Let me say 1, 3, 2, 4, 5, 3, 5, 6, 8, 12. Now I want to run this. Control Enter. Okay, I can't see the console. Let me go back to the console. Sorry. What's happening? My R Studio is not responding. Just give it a minute. What is going on? Sorry for that break. So I created this vector like this now, as you can see here. So if I should call VEC, this is what is inside it. These numbers. Now, if I want to call the guy in the third position, I can do this. VEC, then the square bracket 2. That's just a single bracket, not double square now. No, in the third position, double square bracket 3. Indexing in R starts from 1. So the person in the fourth position is 1, and the person in the fifth position is 5. So if I want to call the third element, I just write vec and put 3 in a square bracket. If I should run this and see, it gave me 2 because 2 is the one in the third position, as you can see in the console here too. Now I can also put a double square bracket like this and put 3. To still give me the same result. But this double square bracket is usually used for data printing and list. So I think it works with matrices too. So, but for vector, it doesn't really matter. So now I cannot use ampersand sign for vector unless I gave this, what was it called? This vector a name. That is, I give each vector a name. What do I mean by that? I will talk about that. Now let's say I want to call maybe the third, the fourth, the fifth, and the sixth element. I can say in square bracket, I'll put 3 to 6 like this. And do this. So let me increase my view. Zoom in so that it's not coming up. So don't just hold on again. I'll say it's slow to respond. Okay, okay, I think I responded now. Oh, still coming up. Oh, no. Sorry, sorry for this. Wow. How do I have that open comments? Okay, my house studio is back now. Sorry. So if I want to call the third, the fourth, the fifth, and the sixth guy, I can just do this. If I should run this, I don't know why it's just slow to respond. And I don't want to restart. It's already late. I don't want to start this. Why is it not? Sorry. I don't know why it's taking time to respond. So you can see gave me 2, 4, 5, 3. That's the guy in the third, fourth, fifth, and the sixth position in that order. Let me try and stop some first. Okay. So another way I can do this, I can just manually say C into bracket 3, 4, 5, 6. This is going to give me the guy in the third, the element in the third, fourth, fifth, and sixth position in that order. You can see I have the same result. Now I can exclude. So let's say I want to exclude the first 3 elements. I can just simply say minus. I'll use the minus sign to do that. So minus C into bracket 1, 2, 3, or 1 to 3. Anyway, I want to write it. So if I should run this, you can see it has excluded the first 3 elements, which is what 1, 3, and 2. It has been excluded and it brought out the rest. I hope that is well understood before we proceed. Okay, so that's vector on that note, but we're still going to talk about matrices and data frames as we proceed. Here we are trying to use the sample function. So what is this going to do? The sample is going to work on this data 1 to 6, give me 10 samples, and what using replaced equals true. So this is going to give me random numbers between 1 to 6 It's going to pick random numbers between 1 to 6, 10 multiple times and give me a result. So for this guy, the first random number it picked was 2. The second time it picked 2 again. Then the third time it picked 5. Then it gave me 5 samples in this regard. Now replace equals true means after I pick the first guy 2, replace the 2 again, still pick from 1 to 6. Then you can do replace equals false. That you want to pick those values without replacement. So that's about using a sample function. And also here we talked about set.seed. So what does set.seed mean? You know, when if I'm using this sample function, for example, is picking random numbers. Now, if I should run this sample here, this sample function I ran here, if I run it once, if I come and run it again, I'm going to get a different result. But let's say anytime I run this sample function on a data set, I want to keep getting the same result I got yesterday, and I want to run today, I want to get the same result. Then you're going to do this set.seed. You are going to run this set.seed command. You can put any number into it. Person using 1. It means whenever I run this command on the data with this seed value of 1, anything I get now, if I want to run tomorrow and I want to get the same result, I will use this value of 1. So that's the essence of using this set.seed function. Okay. Now, there's a function that's also very essential, which is called duplicated function. So this duplicated function, what does it check? It checks if there are duplicate values in a vector. It can be you can even use this, but usually use vectors. It makes more sense to find duplicated, to use duplicated function on vectors rather than matrices or data frames. So here I'm running duplicated function on this set of vectors, on this vector rather. I have in this vector 1, 2, 1, 3, 1, 4. Now, if I want duplicated on this guy, it takes the first guy. For the first guy is not going to be a duplicate, obviously. So it's going to return false. Then by the time it goes to the next guy, what it's just going to do is that it checks, have I seen this guy before? Or is this guy the same as the previous values I've seen? If it is a no, it returns false. And it goes to the next number, which is 1 here. Because 1 has occurred before, it returns true. That meaning that it's what duplicated. And it goes to 3. 3 has not occurred before, it returns false. 1 has occurred before, it returns true again. 4 has not occurred, so it returns false. So it means I have 2 duplicate values. By the time I remove these 2 1, this 1 and this 1 here, so it means it's not going to contain traces. So it returns true for duplicate values. That's what it just does. Now, in this next line, you're talking about removing rows with missing data. Now, what this one does, this na.omit function is going to remove if there is a duplicate value in a particular vector at all. That is, now missing values are usually denoted with NA, which means not available, not applicable, or unknown. So in this guy now, so for example, I have this vector VEC I've created. I can check duplicated. So let me run the duplicated command on it. Duplicated into bracket VEC. Now you have this result: false, 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 false. Then true here because 3 has occurred before, as you can see here, and also 5 has occurred before, as you can see here. That's why I have this true here. Then also NA dot omit is used to omit missing values, that is NA values. So if I want to include NA values here, I can, let me say I want to put NA values inside this B cells. I can say comma NA like this. I want to include another NA values, so comma NA. Sorry, NA. So I want to include NA in VEC now. As you can see here. So if I should run VEC now, you can see that the vector now has missing values. Now, if I should do NA dot omit now, NA dot omit in the bracket VEC. So let's see what it's going to give us. As you can see, it returns the vector here without what? Without the NAs. So that's what NA dot omit does for you. Now, let's say, for example, you want to even check whether there are missing values in a data set or a vector. You have the is.na function that you can use. Is.na. So it just means is there NA values? So I can pass the VEC value inside it. Then if I should run this, you can see it's going to return a logical value or a logical vector having true if there's an NA. So you can see true here because there's NA in this position and there's another NA here. That's why you have two trues. True here and true here because I have two NAs. So return true for where there's what? NA. Okay. Please stop me at any point if you don't get the concept. Please do what stop me. Now, please take note. NA dot omit in lowercase everything. So it's not NA dot capital O omit or something. And then this the brackets is important too. Now we're talking about subsetting using the ampersand sign, that is the dollar sign. I said you can use it to call a single vector by using the name. So for example, I have the iris data set that I've already called in this app session. So let's say I want to call sepal.length column, the sepal.length column in iris. I can just say iris and I'll put the dollar sign after it. Then obviously it's going to give me this pop-up. It means that these are the available columns I have in this iris data set. So I can just pick this. It's just going to give me what I have inside this column as a vector like this. So you can see this is what is inside iris, the sepal length column in iris data. Now, another way I can get this information is that by position. I can say iris double square bracket, sepal length is in position 1. So I can just put 1 and I will call it. You can see I got the same result. This is iris sepal length also. So even if you want to be sure that this result is the same as this result, then you can say iris. Sorry, I said iris. I can use the identical function. Identical. Then I'll put the first guy that I want to compare into this. Then comma the second guy I want to compare. Then it's going to return true if they are actually the same thing. So if I should run this, you can see that it returns true. So it means that this is actually the same as this. But now look at the way it's listed. It gave me the result. This is vector format. This is what you can see. You can see that it gave me in a listing format, not in a column wise. Now, if I want to get it in a data frame format, I can say iris in square bracket, just one single square bracket. Now, I need the first column, column 1. It means give me all the rows, but the first column. Now, there's nothing to the left of the comma, meaning that I want all the rows. This means row, comma, column, row, comma, column. But since I want all the rows, I didn't specify anything, but I just want the first column. That's what this one means. So if I should run this, you can see I have the same result as what I have here. So that's where you
Yeah, I
can
don't
subtract. You
understand.
can also, so yeah, is it this line you are talking about?
There's the two line, the one you highlighted now. That is one and identical.
Okay. This one, you know what these two means, right? This line 25 and line 26, right?
No, I only know 925. I don't know 926.
This line 25 is calling the stepper length column in the iris table. In the iris
Yes.
table. Now this is calling the first column, which is the same thing as the stepper length. The stepper length is the guy in the first column. So I'm just calling it by position. Do you understand? So this identical is like, okay, I'm trying to compare two values. Like, are they the same? So since this one and this one are the same, if I put them identical, so I'm saying this result, comma, this result. Let me to check if they are the same thing. So that's why this one returned true, telling me that they are actually what the same thing. Do you understand?
Yes, I do.
Okay. Okay. So this one is also doing similar. This one also works similar to this. I'm saying that return iris, give me in the iris data, return all the columns, but give me just the first, sorry, return all the rows, but give me just the first column, which is what the separ length column, separ dot length column. So because I'm not putting anything here, it means give me all the what, all the records, but just give me for the what, for the first column. If I want it for two columns, I can put maybe the first and second column. I can put 1:2, meaning give me all the records for the first and the second column. So if I should run this now, this is what I have. Um, so you can see I have the first column, which is separ dot length, and I have the second column, which is what separ dot width for all the records. But if I need specific rows, I can say iris into square bracket. Let's say I need the first 50 rows. I can say 1 to 50 for the first and the, give me, so let me just say first 20 rows, 1 to 20, or first 15, 1 to 15. So if I should want this now, you can see I have 15 records returned. You can see 1 to 50 for what? The first column and the second. Do you understand?
Yes.
I didn't hear that. What did you say?
Okay, yes.
Okay. So here, what we are trying to do, we are trying to perform some arithmetic on columns of a data frame. So in here, I'm trying to say that, okay, divide this column by this column. I have the separ dot length column and the separ dot width column for the X data set. To give me this divided by this. So this operation will be what? Assigned to X. So here I'm trying to see the first 6 records. So if I type head of X, I'm going to see the result of this operation. As you can see, I have 1, 2, 3, 4, 5, 6 values. So this is separ dot length divided by separ dot width, and that's just. I'm sorry. I would have to stop the class here, and we have to continue tomorrow. Uh, I, I hope we do have 1 or 2 questions to ask before we end the class. Sorry, I have to end it so soon. Do you have any questions so far? We still have a lot to cover. I know. Hello? Can you hear me?
Hello.
Yes, I
Yes,
can.
you can. Please.
Do you have any question before we call it a night?
I said I'm coming, please.
I'll come with your question.
Yes.
Okay. Hello, Titi, Abatunde, and Ayola. Any question before we round up?
No question.
Okay. Uh,
None for now. Please, Emmanuel, will we have access to the video?
I'll make provision for the video during the week.
Okay, thank you.
All right. You're welcome.